Alright, so this is our last part of lesson 3.8. We're going to be solving rational inequalities. Alright, so here's example 7 from your notes. And so we've already done the rational examples where we've already talked about where to find an inequality. First have to find where they're equal to each other. So the first thing we'll do is find out where these two are equal to each other. And that will be part of our solution because of this inequality. So we're basically going to solve this proportion. So to solve this proportion, remember we got to cross multiply. So we end up with the equation and this is a quadratic, so we're going to get it equal to 0 and factor to solve. So we'd end up with x squared plus x minus 12 equals 0, and that will give us the solutions of x equals -4, and x equals 3. But now we need to consider something else. Since these were fractions, we need to consider or make sure that we have no division by 0. So this is a biggie. So we need to consider both of these answers, go back to the original, and make sure none of these will produce division by 0. We also have to think about the solutions of each of these separately to make sure we don't get division by 0. So we're going to plug -4 into each of these. So we'd end up with 1 over 35 equals 1 over 35. So here we're checking -4. So it works. It doesn't give us division by 0, and it makes the equation true. If we check x equals 3, we see that in that first ratio, we'd get division by 0. So x equals 3 has to be excluded because it would produce division by 0. Our other considerations for division by 0 would come from the solutions to this equation. So we need to know where that's equal to 0. Well, that's factorable. So that's at x equals 3 and x equals 1. We've already talked about the fact that x equals 3 cannot be a solution. So now we need to check x equals 1. If we plug in 1 for x, we're going to get 1. So now we're going to check x equals 1. We get 1 over 10, and then on the other side we get 1 over, let's see, 1 minus 4, we'd get 1 over 0. So x equals 1 is not a viable solution because that, again, would also give us division by 0. So if we think about our number line, which is the tool we've been using to figure out if we know where it's equal to 0, where is it positive and negative, or comparing this greater or less than, we have to consider all the places where this was equal to 0 because those are values we have to exclude, and then we have to figure out values where it was equal. So we have to consider on our number line -4, 1, and 3. We have to realize that we can't use 1. Cross that out. So I'm going to put an open dot indicating that we can't use it. We can't use 3, but we can use -4. So I'll put a closed dot. Now we need to figure out what's going on in between all these numbers. So the same thing we've done with all of our other problems, we're going to test values in between here. Now with this, we do need to actually find the values. It's not just about the sign. So we need to find out whether or not some value less than -4 will make this inequality true. And then a number from each interval. So let's say I choose -5 to test for this interval. So I'll put -5 in for x, so I end up with 1 over 15 plus 25 when I put in -5 for x. And I need to also evaluate the other side. I'd end up with 25 plus 20 plus 3. So I basically end up with a ratio 1 over 40 on the left, and on the right I end up with 1 over 48. The left side is greater, so this value of -5 made this true. I'd have to go ahead and test values for each interval, and then I'm going to mark whether or not it makes it true or false. So let's pick a number in this interval. For example, 0. I'll make the math easier. If I plugged in 0 for x, I'd end up with 1 over 15 and then 1/3. 1 over 15 is not greater than 1/3. It's less. Therefore, this was false. Test a value in here, such as 2. I'd end up with 1/5 on the left compared to on the right. I end up with, hold on, let me check that again. With 2, I end up with, 1/5. If I put in 2 on the right, I'm going to end up with -1. 1/5 is greater than -1, so that's true. Now I'm going to test a value greater than 3, such as 4. So I'd end up with -1/5 on the left, and on the right I'd end up with, if I plug in 4, I'd get 1/3. -1/5 is not greater than 1/3, so this is false. So now if I consider where it's true, I'd have all of this being true, and then all of this being true. So our solution set are all the numbers less than or equal to -4, all the numbers in between 1 and 3. Alright, now we'll try example 8. So first let's consider that I can't have division by 0. So let's figure out where that would occur. So division by 0. It would be where x squared minus 4 equals 0, and where 2x plus 4 equals 0. This would be equal to 0 at x equals 2 and -2. And this would be equal to 0 at x equals -2. So if I'm looking at my solution set on a number line, I'll put it down here, I would have to put an open circle above -2 and 2. Now I need to figure out where these two ratios would be equal to each other. So cross multiply. Get 0 on one side. See, that'll factor into x minus 6. No, x minus 4 and x plus 2. There we go. So it'll give me x equals 4 and negative 2. Remember, we've already considered negative 2, and we know that can't be. X equals 4 if we consider that. Check it. 1 over 16 minus 4, so 1/12, does equal 8 plus 4, 1/12. So check all your answers. So we see that 4 is an answer, so I'm going to put a closed dot above it. So now I need to figure out if values in here, 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 and here, all these intervals, would make this original problem true or false. So we would test, for example, something like negative 3. So if I put in negative 3 for x, I'd end up with 9 minus 4, so I'd end up with 1/5. And on the right, I would end up with negative 1/2. 1/5 is greater than negative 1/2, so this makes it true. I'm going to pause. I want you guys to test numbers for each of the regular intervals, and after you've done your work, start the video again to check your answers. Alright, so if you look at your number line, you should have the interval between negative 2 and 2 is false. I checked the value of x equals 0, and you get negative 1/4 on the left and 1/4 on the right. And it was also false for any number greater than 4. I checked 5. So your overall solution is what I have circled here, x is less than negative 2, or it's any value in between 2 and 4, also equal to 4. Alright, you guys need to do example 9 on your own. Pause the video while you're checking and doing number 9, then come back and check. Okay, so hopefully you finished example 9, you're coming back to check your work. So you'll see I first considered division by 0. I need to exclude negative 3 and 2, which is why on my number line I have open dots above those. I figured out where they were equal to each other, which was at 5 and negative 2, which is why I have a closed dot above those values. And I used a table to organize all my work, so I had to test a number from each of these intervals, and you'll see the number I tested in my work, and then the conclusion about whether it made the original inequality true or false. And here is a number line of my solution, and here is my answer written using inequalities. If you have a graphic calculator, you can input this as one function, the other side is another function, and then use the table function of your graphing calculator to find these values. It definitely makes the work a lot easier. Otherwise, you're just going to have to plug and chug, be patient, take your time, and check your work. Alright, so tomorrow I will not be in class, so tomorrow you will have an assignment with practice problems like examples 7, 8, and 9.